Hello students, and welcome to the second video of this lesson. In this video, we're going to really start to dig into the second derivative and its relationship between f prime and the original function. So let's get started. So as I'm looking at this, we know that the first derivative is going to tell us maximums and minimums, where the function's increasing and decreasing. And along with that, if we were to go further and we were to take the second derivative, it would also have identifying remarks. In this case, it will tell us where the function's concave up, where it's concave down, and where it kind of snakes away, which is what we call like a point of inflection. So you also want to think that the second derivative is the first derivative of f prime. I know that's a little bit convoluted, but really get that down. So all the same relationships are going to apply between f prime and f double prime. So now I want to come through and I want to complete this table. So we're going to be looking at several examples where we're actually going to be talking about these connections between f prime, and f double prime. All right, but you are going to have your homework. You're going to have plenty of practice over this, okay? So what you want to think about is when the second derivative is 0, or when it's undefined at some value, then the original function has a point of inflection. Well, it's a potential point of inflection. But you also want to think that f prime is going to have a potential maximum or minimum. Along with that, when the second derivative is positive, when it's greater than 0, then the function is going to be concave up. When the second derivative is negative, when it's less than 0, then the function is going to be concave down. Okay, and then again, the connections between the second derivative and the first derivative. So then basically what you want to do is just take out these little derivatives here and take one out here. So if the derivative was greater than 0, then the function would be increasing. If it was less than 0, it would be decreasing. So those connections still happen whether or not, because there's still the connection between the first and second derivative. It's the first derivative of the first derivative. So when we have some changes from positive to negative or negative to positive, we have points of inflection. And you don't have like it doesn't change whether it's going from concave up or concave down. It's still going to be a twist in the graph. It's still going to be a point of inflection. And so we don't identify whether it's coming from concave up or concave down. But you do want to realize that f prime is going to be a relative maximum, or is going to be a relative minimum there. So then here on the last page in the previous video, we actually found the first derivative of x plus 2 to the 2/3 plus 1. We already found that. And so now we want to find the second derivative, and we want to make a sign chart, your handy dandy sign chart, to determine intervals of concavity and points of inflection. We're going to be looking at that here, okay? So the second derivative, let me write f prime of x again like we had. So we had here f prime of x was equal to, let me write it as 2/3 x plus 2 to the negative 1/3. And so when I take that second derivative, okay, I'm going to bring that negative 1/3 down. So then that's going to say negative 2 over 9. And I'm going to get this as x plus 2 to the negative 4/3. And I'm just going to rewrite that real quick. Negative 2 over 9, x plus 2 to the 4/3 in my denominator. Okay, and again, for the same reasons, when we set this to 0, like we did in the last page in the last video, when we set this to 0, we know that it is undefined so it's undefined. Let me actually write that. Undefined when x equals negative 2. Again, for the same reasons as stated in the previous video. So we're going to make a handy dandy sign chart, and we're going to put in negative 2 right there in the middle. And again, this is f double prime. This is the second derivative. And so I want to be examining what's happening. Well, that numerator is going to be negative. Let me choose a value less than negative 2. So like negative 5. All right, so negative 5 plus 2, I'm going to get a negative, but to the 4th power is going to change positive. Then the rest of everything is going to just stay positive. So all of this is going to stay negative. And then let me check the other side of it. So if I go 0, well, that numerator, again, because it's negative 2, is going to stay negative in the numerator. And then my denominator, 5 plus 2 or 0 plus 2 or whatever, to the 4th power, cube root of that times 9, that's all going to stay positive again. So this entire area is going to stay negative. So we want to stay, okay, well, what's happening? All right, so based off of our sine chart, we know that f of x is concave down. And you can abbreviate it like that, don't worry about that. So f of x is concave down on negative infinity to negative 2 union negative 2 comma infinity. And we know this because, well, we've done all this work and we know that the second derivative of x, the second derivative of f of x is negative. It's less than 0. Okay. We know again that it's never concave up. And since there's no change in signs, we also know that there's no point of inflection. All right. So, let's actually think about this. Well, let's look at this previous page where we were going over this, and let's actually state, okay, well, look at this concave downness. Okay, you see that it's concave down as x is greater than negative 2. And on the other side, when x is less than negative 2, it is also concave down. It's got that concave down shape. All right, so based off of the results that we saw from our handy dandy sine chart of the second derivative, we can see here that the entire time it is concave down. Now there is a minimum. We do have a relative minimum. In this case, it's an absolute minimum. But we do know that there's a minimum, but there's no point of inflection. And so you do want to identify, okay, what's the difference between a point of inflection and maximums and minimums? Because there is a difference. So now as we're going through these things, we want to identify, okay, what are all the relationships? Like, what are all the relationships that identify everything together? So really put some deep thought into your answers here, because you do want to be the ones making these connections. And in fact, actually pause the video here and try to make these connections between the statements on the left side here and then the statements over there on the right. Because what's going to happen is that everything that you see, everything that you're going to notice here, everything that I'm going to write down, you're going to want to make a notation of that in your brain on your own. Okay, so don't just, of course, never just blindly copy what goes down in these videos. Actually think about what they mean. And so I'm actually going to give you time to fill out this list on your own. All right, so let's go through these real quick. So if f of x is increasing, we know that the first derivative is greater than 0. If f of x is decreasing, we know it's less than 0. When f of x has relative maximums or minimums, again, we're talking about the first derivative in these first few, it's equal to 0. And a new one that you want to kind of think about, if f of x has a point of inflection, well then the relative, well, f prime has a maximum or minimum, or a relative maximum or minimum. For number 5, when f of x is concave up, we know that the second derivative is greater than 0. When it's concave down, we know it's less than 0. So think about up, it's positive, down is negative. So that helps simplify some things in my mind. And when we have a point of inflection, we know that the second derivative is equal to 0. Or I guess it could be undefined. So when is f prime of x increasing? Well, since we're talking about the second derivative, we're just, again, you want to just take out. So if f is increasing, we know that the derivative of that function is going to be positive, greater than 0. If a function is decreasing, we know that the derivative of that function is going to be negative, less than 0. And then along with that, if it has a relative maximum or minimum, we know that it is equal to 0 or undefined, or the derivative of that function. So I kept saying it like that because you do want to simplify these things in your mind. You don't want to be focusing on f, or if I have f prime, what is f double prime, like what are all those things, second derivative, like just worry about the connections between a function and its derivative. Okay, so if f prime has a point of inflection, we know that the second derivative has a relative max or min. If f prime is changing from positive to negative or negative to positive, you have maximums and minimums. If f prime has a relative max or minimum, then you have a point of inflection. And then the second derivative, if that changes from positive to negative, then we know that the first derivative has a relative max. And then for the second derivative, if it changes from negative to positive, we know that the first derivative has a relative min. And again, simplify those things in your mind. Just take out some of those hash marks and think about the connections when you take out a hash mark from either of those sides, okay? So for the end of this video, I want you guys to kind of think about doing these card matches, okay? What's really nice is if you're able to actually cut out these cards here in the next few pages, and so you can lay them out and make connections. I have plenty of these things. If you want to actually do some of these things with your hands and you're one of my students, actually come to me in person, well then I have plenty of these card matches that you can actually tangibly feel and connect things, okay? But what you're going to want to do is you're going to try to make connections between F prime, and F double prime. And like I said, there are plenty of these things out there, but here I've put the answers. Again, don't look at the answers yet, just try to match up the cards as well as you can and then come back and check these answers, okay? I really want you guys to do that as you're going through these, because these answers here, this isn't like everything, okay? You really want to be focusing on yourself. Like, it's fine if I just put the answers on a video and you copy it, but then what are you actually getting out of it? So keep that in mind, that you want to be the one doing the brain work, putting the effort into these things, because you're the one who's ultimately going to make those connections. You're the one ultimately going to have to perform on the AP calculus exam, which I know, again, you guys are the best students, so I know you guys will be able to perform and give it your best effort when it comes time to that in May. Of course, if you don't get any of these answers that you see here, and maybe you're making some different connections, you want clarification, guys, please just reach out to me. Students, you guys know I'm here to help. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.